All right, so I just want to echo everyone's comments about, thank you to the entire Intel team and such a great partnership and really great to work with. I've been a part of various open source communities over the last while, and it's really a great experience working with them. So the goal here is we presented last year on some of the initial updates, and I think we've progressed over the last year in terms of our thinking, and now we're asking a little bit harder questions of ourselves in terms of what does DAOS mean in the cloud, and so that's what I want to get through today. This is an eye chart. Don't worry too much about it, but the main point here is to say that we're dealing with a pretty complex system in terms of what we're trying to target for the HPC users. We have on-prem deployments. We have a series of different services in the cloud around scheduling, the types of nodes they're going to pick, and then as well as all the storage that they're going to leverage and how to monitor all of that. But then in addition to that, we also have all of the services that also exist in the cloud that many users are not just interested in, one type of thing. They want to take advantage of a variety of different services. And so then how do we integrate that into the overall workflow? And by the way, sorry, I forgot to introduce myself before. My name is Dean Hildebrand, and I'm in the office of the CTO at Google Cloud. I've been there for about 5 years working on our storage strategy. So in terms of focus, the titles are all pretty straightforward in terms of high performance. But what I want to get into is some of the interests, our interests in the area. So I'm going to get into some more questions about how to integrate object and DAOS later on. But at this point, I think this is sort of just a high-level version of what we're thinking around. There's always this question about what storage system do I pick in the cloud? And so, objects are great at really many things, but let's say low latency is not one of them. And so when you really think about low cost and high bandwidth, that's where object really shines. But you start to get into things like the file API, latency, small random IOs, and all these types of workloads that are out there, right? That's where then DAOS will really become an augmentation to that storage system. And object will then turn much more into an archive or a warm tier, if you will, for the storage data. So, easy, right? This is sort of something that we've spent that's the thing we can do immediately, right? Is how do we just make this really easy to deploy in the cloud and just get users who are not HPC experts by any means, and definitely not storage experts, up and running with DAOS as quickly as possible. So we've implemented 2 different ways to do this, and they build on top of each other. The first one is we worked with Intel to develop all of the Terraform scripts that you can find online. And this is a really good option when you already have everything built out in your system. You've already, there's a lot of users that already built all of their workflows and everything else, and they just want to slot the storage system inside of that. And so then just going straight to Terraform is a really easy way to do that. But actually, we're thinking much bigger than that for most users, where they don't just have, if you go back to that original picture that I showed, they have schedulers, they have login nodes, they have entire clusters that they're dynamically creating and destroying throughout the day. And so that's why we built Cloud HPC Toolkit, and the TL of that is actually in the back, Carlos, if you want to ask more questions afterwards. And so what this does is really provide an open source pluggable layer that creates blueprints of your entire HPC cluster, and then something that you can generate Terraform templates for and then create them and destroy them, augment them as you go forward. So it's really like a cluster in a box, if you will, or a cluster in a shell. So we've integrated, more specifically, Carlos and the Intel team have integrated DAOS into the HPC toolkit. And so I thought I would just give, I know it's a bit small, but a really simple example where in a few lines you can have your servers laid out and the types of servers that you're looking for, and we have predefined templates for different workloads that you can deploy. And then here, I've also put in a really basic thing that we have called a MIG around how we deploy our clients, which is basically you specify the number of clients you want and it spawns them up and it keeps them alive. So those are two really easy. You create this blueprint and then, using our GHPC command plus a couple Terraform commands, and you're up and running with the cluster. So the key point here is that this is a really simple example. You could replace this with a Slurm queue to launch your clients off on the image, or you could replace it with whatever you want, right? And you can start adding and changing that as you go forward. So this is really, again, part of the larger thing to make HPC really easy. All right. So the other key point is, if it's not fast, what are we doing here? So the strategy there is really around, we have a very limited environment, right? We can nail it down to like, these are the best images, these are the best computers, these are the best storage systems that will help your DAOS system. And so we can really limit it. And then with those, we can just pre-tune everything and make it work out of the box. So in terms of our interest at the moment, we're getting a lot of requests for the diffuse layer and the POSIX support. But as well as on the AI side as well, which I guess isn't too surprising. I think some interesting questions there is, and what Joanne had mentioned is around, there's more frameworks that we can tackle at this point. And so I think the POSIX and the diffuse layer is going to end up the default use in many cases for a lot of these other frameworks, such as JAX and others that are emerging. And so I think that layer is always going to be critical to provide sort of a standard layer of support for a variety of users. And then for sophisticated ones, they can start to use the more direct plugins. And then the other point, which probably is relatively straightforward, is, we're very interested in the TCP stack, obviously, and that doesn't mean not RDMA, but it means on the TCP side, right? So that's where our main focus at Energy is going. And so per dollar, and this is something that I want to get into more of a discussion on, is so we've been running some experiments last year, and so we've run a few more. We unfortunately haven't been able to try out the new parity rotation patch. And so, we're still hitting some issues there on the read side. On the right, though, you can see, we're hitting about a 20% degradation when we turn on erasure coding. I think this was 8+, it's 8+2. So we're pretty happy about that. I mean, that's a relatively small hit given the amount of availability that we get by doing that. And then we're losing about 2/3 of the performance right now when we switch from easy to hard write, which I think we're actually pretty happy with. That is, like, if you look at other entries on the IO 500, some of them are going down by way more than that. So we're actually pretty happy about that. And I think, I'm trying to remember, but I don't think this also has some of the TCP libfabric patches inside of it either. So I think we're also expecting that as the latency goes down and the scalability, that we'll get better performance here. So on the read side, again, this had the EC rotation bug in it, so we're getting some degradation on the read side. But again, we're pretty happy with the scaling, and it's pretty much maxing out the SSDs and the networking that we're giving it. So yeah, anyways, just as an update on the performance, and then the erasure coding to keep the system up and running. On the metadata performance, again, so this is deployed using RAM. And so, we're seeing about a 50% drop, but again, we're pretty happy with from easy to hard, and that's a pretty good place to be in. And as we add clients on the right one, you can see the performance just keeps going up. We, tend to stop somewhere, so I'm not sure if it would go up much higher than that. But anyways, we're really happy with the scaling that we're seeing so far. Let's see. So here is sort of more of the discussion area, and I got into it around making it the amount of performance you're getting per dollar as high as possible, because that is in direct sort of balance, if you will, with the resiliency of the system. The more resiliency you're going to put in, how much does that affect the performance that you're getting? So these are a variety of features that we're looking at. Obviously, we're interested in the non-disruptive upgrades. If you're trying to build a service that has a certain number of nines, this will be critical for that service. Same basic premise applies to the client server compatibility, right? We want to be able to upgrade the servers without worrying about, having clients immediately have connection problems as soon as we do that. So figuring out a cadence and figuring out a way to get a certain amount of backward compatibility and making sure that that is, repeatable is really critical. As Joanne mentioned around data rebuild in the cloud, there's a lot of, it's not as straightforward as it sounds, but there's a lot of times where you don't need to rebuild and the server will come up immediately. And there's other cases where you do. And so figuring out when the best policies there and how to adapt to the different systems, I think is definitely an area of focus. The all-in VME patches without PMEM, I think that it was pretty clear that as hard as we tried, customers just weren't demanding PMEM in the cloud. And so it would have been a pretty long road to deploy it widely and in every zone and region in which we operate, which is really the advantage here, right? We're not looking to get users funneled into a single zone. We're really looking at this as a global deployment. And so, moving away from that model and then into something that is a little more generic, I guess would be the best word to say it, is definitely an area of focus. I will say a weird side note, though, that a lot of times nodes fail, not because of the SSD anyways, or the RAM. And so there is an interesting balance on how much extra durability we get by putting on NVMe versus just picking a new server and rebuilding. So, there's an interesting balance there as well. I think a lot of that interest is around, can we bring down the amount of RAM per node? Because that is a huge part of the cost of the storage server. And so the more we can bring down the cost of that storage server, the more cost effective, again, back to the performance that we're looking for. So I think that's, to me, is the real interesting angle here, in addition to obviously increasing the durability as well and availability. And then the object store integration, I think, is a key part that, I didn't get into. Oh, here it is. Get into here. How much time I got? Okay, so this is then an area where we spend a lot of time talking, and there's different storage services you'll notice in cloud, and each of them sort of follow one of these two models generally. One of them is whether the storage system itself, so DAOS would be the source of truth. So this is the second one. And it just needs a cheap tier for storing cold data. And so then the object store would become that cheap tier. It's pretty hard to create a tier that's cheaper than the object store. So it's a pretty good use for that. The great part about this is that this is how people think about storage systems today. You have a very large storage system, everyone shares it. You don't really know that there's data being tiered in the background, but it just kind of happens transparently to you. The downside with this model, though, is that the data gets locked into that storage system, which can then prevent access from other services that we offer as well. So thinking about BigQuery or some of the ML systems and a variety of other ways, how do they get access to that same data set? And do they have to go through DAOS in order to get access to it? Or can they go around DAOS and straight to the object store if they don't need the extra performance that DAOS offers? So that's sort of the one side. So on the other side, though, if you think about DAOS as a cache of what the data, but the source of truth of it is actually in GCS, in our object store. And that model, then you really provide this landing space for low-cost data inside the object store, where it can be uploaded from on-prem, it can be shared globally, it can be accessed by all the different services. But then, as well, is when DAOS is needed and there's that extra performance boost that you're looking for, then it becomes a cache of that data, and it can accelerate, easily 100x, if not more, if not 1,000x in many cases, of the performance of the object store, just because, again, of how that works. So we're looking at these two different models, and we're definitely looking to partner with folks around, how to integrate these two. I think we're definitely leaning in the cache direction at the moment, where data can get moved in and out from the object store, and it really becomes that acceleration layer. And that's it. So key point is, if you go to the DAOS docs, you can find all the links to the Terraform and HPC blueprint code that we have out there, and it's ready to go today. So any questions? Kevin?
Model like you're like, oh, this is cold data, so
right. I mean, that would be the plan, right? Through a policy-based mechanism. I think in either model, the ideal way would be some sort of policy-based mechanism of moving data back and forth. It's just more or less in one model, when DAOS is the source of truth, you could combine small objects together. You could make it a much more efficient option to the slower back end. Whereas in the other model, you wouldn't be able to do that, right? Because the goal is to not convert the data in the object store into a proprietary format. Does that make sense? Yeah. John?
There must be other files available. How do you all help customers choose which files?
Yeah, you should join along on a customer call sometime. But I think, there's a variety of different ways, right? Some of them come at it from the one that they're most comfortable with. Some of them in the sense of, let's say, Luster, they know it, they use it on-prem, they were asking for it, look, I have a system in, they understand how to use it. Same thing applies to GPFS and those types of deployments. The other ones are basically, like I said, back down to the workload, right? So beyond that, is it a object-friendly workload? If it is, that is definitely going to be the lowest cost way to manage your storage and access storage. And so then it really goes from there, right? It's like, well, does it match that type of workload? No. Okay, well, then what other options are there, right? And so then if they're looking for this type of low latency and the scalability, I think then that's where, DAOS will exceed both of what the object store can provide, but as well as what our NFS, we have a few NFS services as well, and then when that can provide as well.